We've learned about rate of change and domain. Now let's move on to sketching graphs of linear functions. So we have here a linear function f of x equals 2/3 x plus 2. Notice that this function also comes with a domain. It says that x must be between -10 and 5, or -10 is less than or equal to x is less than or equal to 5. So in order to account for this on our graph, there's one thing we need to do. Looking at my domain, I'm going to sketch out some boundary lines to help me when I get to the point where I'm graphing my function. Let me show you what I mean. So I know that x cannot go below -10, and I know that it can't go above 5. So I'm going to look at the x-axis. I'm going to navigate over to x equals -10, and I'm just going to draw in a dashed line to help me remember that my function is not going to extend beyond that value. And I'm going to do the same thing at x equals -5. So this isn't actually part of the graph of my function. These are just guidelines to help me graph correctly. So now looking at my function, I've got f of x equals 2/3 x plus 2. Notice that this is, although it's a function, it's still in my y equals mx plus b sort of form. And I can still look at it and find that the coefficient of x is equal to my rate of change. I'm using the term rate of change because this is a function. That's why I'm not calling it a slope. And b, the y value of my y-intercept. Remember that we start by graphing b, so I'll go to the y-intercept. B is equal to 2, so I'll plot my 2 on the y-intercept. And then I'll use the rate of change to navigate from there. So my rate of change is equal to 2/3, which means I'm going to go up 2 and to the right 3 units to plot a point. So I'll go up 2 over 3. Let's see, up 2, 1, 2, 3. Plot a point, up 2. And then I'm stuck there. I can't go further because I've hit my boundary. So I'm not going to plot a point. I'm just going to leave that alone and return to where I started on the y-axis. So I can generate points in the negative direction by going down 2 and to the left 3. That'll still stay in line with my function. So I'm going to go down 2 over 3, down 2 over 3, and keep doing this. And once again, I've hit where if I plot another point, it's going to end up outside of my domain. And this is the point of having those dashed lines, so that we don't plot stuff outside of the domain. So now I'm going to draw a line just like you would normally do. Draw a line that passes through all of the points that you've plotted, but I'm going to stop the line right on my dotted lines. To finish the graph of this function, I'm going to look at my inequalities and determine whether the inequalities include the value on the dashed line or not. So since x is greater than or equal to 10, I'm going to plot a closed point on the value at x is -10. Because x is allowed to be that value. It's included in my function. And the same thing on the other side, x is less than or equal to 5, which means that x can be equal to 5. I'm going to plot a closed point there to say that it is included as part of my function. So this is the graph of my function. You can see that it falls between my domain of -10 and +10, including those points. Let's go ahead and do another example. So here I have the function f of x equals -1/4 x plus 10 with a domain where x is between -12 and +12. Just like before, I'm going to start with kind of sketching out the boundaries of my domain. So I'm going to look at x is -12 right here, and I'm just going to sketch out a dotted line for all values where x is equal to -12 to remind me not to go past that. And I'll do that on the other side as well. So the other side of my domain is that x cannot be equal to and x cannot exceed 12. Okay, now I'm ready to look at my function. So I've got f of x equals -1/4 x plus 10. So I know that 10 is the y value of my y-intercept. So I go to the y-axis, I find 10, and I plot my point. The rate of change is the coefficient of x, which is negative 1/4, which means I'm going to go down 1, and to the right, I'm going to go over 4. So let's navigate from our point that we already have using the rate of change. So down 1 over 4, plot a point. Down 1 over 4, let's see, that's 1, 2, 3, 4, plot a point. Down 1, 1, 2, 3, 4. Now I'm not going to plot this point because it falls right on my dotted line, so I'm going to come back. I'm going to have to think about that and come back. And now I'll go in my other direction. To get some points on the left side of my y-intercept, I just reverse what I did here. So I'm going to go up 1 and left 4. So up 1, 1, 2, 3, 4, plot a point. Up 1, 1, 2, 3, 4, plot a point. Up 1, 1, 1, 2, 3, 4. And once again, I've ended up with my point is right on the dashed line, so I'm going to wait before I put a point there. And it's going to depend on, once again, my inequalities. Do they or do they not include that number that's the limit? And in this case, they don't. So we're saying that x has to be between negative 12 and 12, but it can't be equal to them, right? Based on the symbols that we have here. So for the points that we have on the boundary lines, I'm going to plot, and let me kind of clean this up so we can see it better. I'm going to plot an open circle, and this open circle is saying that my function goes all the way to that point, but doesn't actually include it. So I'm going to plot an open circle here. I'm going to go to my other boundary line. I'm going to plot an open circle there. Okay, because again, I'm saying my function runs to that point but doesn't actually include it. And then I'm going to run a line through all of my points as straight as I can. And there's the graph of my function. So I have the function f of x equals negative 1/4 x plus 10, where the domain of x is between negative 12 and positive 12, but not including those points. Let's do one last example. Joaquin is walking at a constant speed of 3 miles per hour. The function f of x equals 3x represents his distance over time, where x represents the number of hours spent walking. The domain of this function is all positive real numbers, or x greater than or equal to 0. Sketch a graph of this function. Okay, so the sketching a graph of the function is what we've been practicing so far. But let's kind of take a look at this one more time, because now we've got this sort of word problem to consider. So once again, we have Joaquin walking at a constant speed. Since he's walking at a constant speed, we know this is going to be a linear function. So he's walking at 3 miles per hour. And they're saying that this function, this f of x equals 3x, represents his distance over time, where x represents the number of hours spent walking. So the domain of this function then, they've given us, but I think we could figure out, because if x represents the number of hours, remember again, we can't have a negative number of hours, but we can have 0 hours, right? So it makes sense that the domain of this function is all positive real numbers, or x is greater than or equal to 0. So really this was just a lot of information, a lot of context, but if we comb out the key parts of it, they're telling us a function, and they've given us the domain. And now we just need to sketch the graph of this function. In the future, as you get a little bit more comfortable with this, there will be examples where they give you the function and you'll have to figure out the domain from context. And then way down the line, we'll get to a point where they give you the context and you have to figure out both the function and its domain. So just kind of keep in mind, as you read these examples, see how they've constructed the function and just kind of confirm in your head that this makes mathematical sense to you. So okay, we have our function f of x is 3x. We know the domain is x is greater than or equal to 0. So let's get to work. So remember to start just by sketching out the boundary of our domain. So in this case, x is greater than or equal to 0. So I'm going to sketch my dotted line along the y-axis, which is also the line x equals 0. So I'm kind of making big lines here so you can see it a little better. So that's my domain. So anything where x is negative is not going to be valid. In fact, I'm just going to even put kind of going to X out this side of the graph in case you can't see the line I sketched on the y-axis. So anything over there is not going to be valid because we can't have a negative value for ours. So now let's look at our function. The coefficient is 3. This is our rate of change. So the rate of change for this function is 3. That means 3, which is equal to 3 over 1. That means every 3 units we go up, we'll go over 1. But I'm getting ahead of myself because I need to plot b, the y value of the y-axis, right? But they didn't give us a value for b. Remember that this just means that we're starting from the origin. There's like an invisible plus 0 there. So I'm going to plot my point at the origin. But since this point is on my dashed line, I'm going to leave the point open for now and come back and figure out later if it should be closed or open. So from that point, I'll navigate and I'll generate other points that are on this function, on the graph of this function, using my rate of change. So I'm going to go up 3, over 1, plot a point, up 3, over 1, plot a point, up 3, over 1, plot a point. Let's do one more. I think it's good to, when you're sketching graphs, to have a minimum, I would say, of 4 points before you draw your line. So notice that there wasn't any sort of upper boundary on x. There was just, we can't have a negative number of hours, but on the positive side, in theory, we could have infinitely many hours that he could walk, right? So I'm going to plot my line. I'm going to do my best to get it through these points. And then just like you are used to doing, I'll have an arrow going in the positive x direction to say, yes, this function goes on forever in that direction. But on the other side, we have to determine whether that lower boundary at 0 will have a closed or open point. Because we're saying that x can be equal to 0, x is less than or equal to 0, we'll have a closed point at the origin because we're saying, yes, this value for x is included in the function because x can be x can be greater than 0, but x can also be equal to 0. So this is the graph of our function. Okay, that's it for today, guys. Hopefully you have a pretty good understanding to start with for rate of change, domains, and sketching graphs of linear functions. Don't worry if you don't feel like a pro yet. This is something we're going to continue building on in the upcoming lessons for class. Thanks, guys.